Welcome to this introduction to our series on laboratory informatics, and thank you for joining us. We've created this webinar series to help you understand the role of laboratory systems in running and managing your lab and its workflows. In preparation for the 2018 edition of their Smart Lab conference, the IQPC group conducted a survey of the driving factors behind investments in laboratory systems. The illustrations on the screen are taken from their brochure. The results are not too different from other surveys. If you order those results in terms of rank, improved lab efficiencies at the top, with streamlining processes and improved data integrity in the strong second and third positions. This is pretty much the same thing you expect to find in any production-oriented organization. We keep running into these same sets of issues at conferences, webinars, courses, and vendor presentations year after year. Although progress is being made, it's painfully slow. Part of the problem is that there's a gap between the skills that people have as they come out of school and those that are needed to work effectively in a modern lab dependent upon informatics technologies. This is the material that people have to learn on their own. It isn't just the details of the products and technologies we'll be covering, but more importantly, how to plan for and manage them. If we want to meet the needs of modern laboratory work and satisfy the driving factors noted earlier, we have to upgrade people's education and come at things from a different direction. We need to realize that traditional science education is just a starting point, and people's capabilities have to be further developed to function successfully in scientific organizations. Meeting the goals in that survey requires a change in thinking. Rather than making incremental improvements in lab work, we have to introduce deliberate design and planning. When lab work was a completely manual process, changes were possible and easily accommodated because people's intelligence filled in any gaps that those changes created. With automated systems, human intelligence is on display in the planning, design, and implementation work, with systems carrying out the tasks. The adjustment that people would have to make has to be built into the system. Data integrity has always been important, but the emphasis on that subject is growing as problems are being recognized. You can't tweak things into improving data integrity. You have to design workflows and systems, either manual or automated, to reflect that need. There are three major goals in this series. The first two are pretty easy to understand. There are a variety of technologies that you can use, so we need to identify what they are, the workflows that they're best suited for, and how to go about choosing those that will help your lab meet its operational responsibilities. The third point may make you a little uneasy, depending on your understanding of information technology and knowledge management. Things that get stored on computers tend to live there forever. Anyone who has a little pack-rat in them understands the problem, and deleting files can compromise compliance with regulatory requirements. You need to organize the material in a way that it can be searched, found, and used. Given the amount of data and information a lab can produce, that can become a problem very quickly. You have to start planning on how to manage the data and information as soon as you can to prevent it from becoming a major headache. We're going to begin this series by defining the ultimate destination for your lab's work, and then move upstream to the processes that feed into it. The ultimate destination, centralized data systems, are the most stable systems, with the processes feeding them the most likely to change. This companion book will provide useful background information on the technologies, support, and other factors that can impact your ability to effectively use these systems. It should prove to be a useful reference as webinars get into more technical detail. While the book focuses on the details of the technologies, the webinar series looks at how to plan and implement systems to meet your needs and the points noted in the survey. Webinar 1 begins by looking at laboratory informatics technologies that have been available for decades. But what do they mean to your lab's operations? This webinar will introduce you to these technologies and help you understand what they offer and whether or not they can be applied to your lab's work. When you're considering lab informatics and automation projects, someone's going to ask, what's the return on investment that you're asking for? How do you answer them? The introduction of informatics and automation technologies into laboratory work will require larger investments than typical lab bench spending and involves people from outside support groups. It also touches on knowledge and intellectual property management, an increasingly important corporate topic. Your ability to address these points within the return on investment conversation will have a direct impact on the approval of your projects. We'll begin by looking into these considerations. How do you justify the expense of laboratory systems? What results can they expect, and how will it improve laboratory operations? How do you go about setting goals that can be easily understood and play into corporate concerns? And finally, how will these investments affect other groups? As laboratory work and the investments in it become more visible to the corporate organization, more effort will have to be put into justification and evaluation of these expenditures. This webinar will help you form the basis for that work. Webinar 3 will look at the technology planning and education, and more specifically, how you can gain the benefits expected from your investment in informatics technologies. Effective planning by people with good understanding of lab technologies is one of the key points in successfully applying informatics technologies to lab work. Most failures can be traced back to insufficient planning efforts. This subject will continue over several webinars. We'll look at the methodologies for planning for laboratory systems. Where do you start, when do you start, and who should be involved? The roles of regulatory guidelines in different laboratories. The roles that lab management, personnel, and IT support groups play. The changes taking place in lab work and the backgrounds needed to be successful, and the effort needed to support the technical work in meeting ROI and performance goals. Webinar 4 extends the discussion of centralized laboratory database systems, that is LIMS, ELNs, and SDMSs, to look at multi-laboratory applications as well as the use of virtual systems, local and private cloud applications, remote cloud, and vendor-supported remote database applications. These topics are becoming increasingly important as cloud technologies become more prevalent. This session will begin looking at the roles that information technology support groups can play in this work. Among the points that will be covered are the planning for multiple laboratory use of database systems, the use of local and cloud-based computing models, and how IT groups can play a role in that work. Why is this important to you? The ability to organize the data and information in your lab is going to impact your ability to make progress in your lab's work. Laboratory information management systems, electronic laboratory notebooks, and scientific data management systems are the primary centralized database systems that can help you do that. But how do you deal with them when your budgets are tight and you may lack the IT resources needed to support them? We'll be looking at that and the trade-offs between on-site and remotely hosted software as a service applications. In the course of the previous sessions, we began looking at the need for outside support for the systems under consideration. What help do you need in carrying out this work, and where will it come from? The 5th webinar in the series will continue the development of that topic. What roles do lab personnel and corporate IT support play in identifying technologies, selecting products, implementing them, and providing for long-term support? Is there a need for additional players in this work, and what is their role? How does this affect you? We're well past the point where traditional IT backgrounds are sufficient to support laboratory work, and yet you need support. This presentation will look at how we develop people to fit that need. Webinar 6 will focus on instrument data systems. They represent a critical transition in laboratory work. It's the place where we stop working with materials and begin working with numerical representations of those materials, where lab bench science ends and informatics begins. Problems in that transition can negate all the work leading up to it and lead to the results that are open to challenge. This webinar will look at those data systems, the processes that affect your data, the choices you face in designing an informatics architecture for your lab, and the silo effect. We'll also look at the roles lab managers, personnel, and support have in selecting and managing those technologies. Why does this matter to you? We're moving toward the development of automated science as a means of gaining higher productivity and reducing costs. If the systems we're putting in place are not well understood and planned, that automation can result in questionable results and missed opportunities. Laboratory informatics architectures have become a major factor in the success of lab operations. This webinar represents an important step in building that success. Everything in laboratory work is done according to a process, and much of what we've covered so far in this series is a discussion of the tools used to improve productivity in lab operations. In the 7th episode of the webinar series, we'll broaden our view to include a full range of lab activities to include the methods and procedures that put the science in lab work. We'll be looking at the informatics pieces, how they relate to each other, and how they relate to the process of lab operations. The considerations that need to be addressed when converting manual processes to automated systems, and what it can take to integrate them into computer-controlled, computer-assisted, and scientific production systems. As the drive for higher productivity and improved ROI continues, laboratories will need to take advantage of the full range of informatics and automation tools available to them. That includes viewing lab operations from a wider viewpoint. This concluding session will bring the entire series to a close so that you can see how to apply the concepts we've covered to your lab's work and how regulatory guidelines come into play. The regulatory aspects are important in maintaining confidence in lab operations and data integrity. The purpose of this webinar series is to help you understand and get the most from your investment in laboratory technologies. If you have any questions or comments, please let us know.